So this is how I'm going to define these improper integrals from now on. If I have an integral from a to infinity, I replace that infinity with a variable t and take the limit as t goes to infinity. Okay. You can also use this if your integral has a negative infinity in the limit on the bound. I want to use b there instead of a. The only difference is that your limit now changes to the limit as t goes to negative infinity. All right. But these integrals are in terms of limits. And we have terminology for limits, like converges, diverges. Do you remember those words we use for limits? So because these integrals are in terms of limits, I can now pass the same terminology to these integrals. Okay? So we can now say these integrals are convergent if the limit exists and divergent if the limits don't exist. Does not exist. Okay, the one thing before we do some examples, I showed you a definite integral here, these improper integrals, when I have a single infinity or a single negative infinity. You could also have both, a negative infinity and a positive infinity. Okay? You only have them when, you need both of the integrals to converge. So if both the integral from a to infinity and the integral from negative infinity to a are convergent, then we can define the integral from negative infinity to infinity, and you just break it up into these two other integrals. The integral from negative infinity to a plus the integral from a to infinity. And this a could be any value. Okay, it just needs to be some fixed constant. So to handle these integrals, where you have a negative infinity and infinity, you're gonna have to calculate two separate integrals. Okay, and each one of those is gonna involve a limit.